Welcome everybody to the on-farm composting best practices for producing, handling, using, and storing, brought to you by the Colorado Produce Safety Collaborative. I'm Adrian Card with Colorado State University Extension and part of the Produce Safety Collaborative here in Colorado. And we'll pass on to my team members and presenters today to introduce themselves.
I'm Seth Urbanowitz. I'm a regional agronomist in Western Colorado, and I'm part of the Produce Safety Collaborative.
Hi, everyone. Thanks for joining us today. My name is Christy Dice, and I'm the Produce Safety Specialist for Colorado, and I'm part of the collaborative as well.
And guys, we're going to turn our videos off and then join you back in video towards the end of the presentation today. So thank you so much for joining us. And on screen, obviously, some examples of compost. I'm going to drive you through how the considerations with this, with the produce safety rules. So compost happens. We're going to define biological soil amendments of animal origin and the compost rule under the produce safety rule. We'll discuss differences between treated and untreated compost. We'll discuss management practices for compost, demonstrate best practices when using, handling, and storing compost on farm, identify health and hygiene best practices for people handling compost on the farm, and identify best practices for managing tools, equipment, and equipment used for composting. Biological soil amendments are either, we can identify soil amendments either in chemical, biological, or physical components. And although the produce safety rule puts some scrutiny and consideration on biological soil amendments, we know these are really crucial to soil health. Lots of soil health interest in our current era, very important, and also very important for carbon sequestration. These add nutrients, they reduce soil compaction, improve tilth, reduce soil erosion runoff, improve water holding capacity, all the things we need in soil health. However, the biological soil amendments are a potential source of foodborne illness in humans, so hence the focus today. And we can further classify these as biological soil amendments of animal origin, or BASALs, as is referenced in the Produce Safety Alliance trainings that many of you hopefully have participated in. These are of specific concern when they are manure, non-fecal byproducts, and table waste, sort of post-consumer components. If they're yard trimmings and stabilized compost, pre-consumer vegetative waste, they carry much less potential for foodborne illness. And those basal products could include manure, compost containing animal materials, these non-fecal animal byproducts listed here, biosolids, which is the treated sewage from municipal sewage product, table restaurant waste already mentioned, and vermicompost. And then specifically to note, untreated human waste or septage is not a basal. So hats off to Christy encapsulating this in a really great table here, showing this continuum based on type, treatment, application timing, and application method. On the far right of this table, you can see the most risky categories. And in the realm of produce, human waste, many buyers would be very uncomfortable with this, so it could be an outlier. So on the left side of the types of these, the non-biological ones we discussed previously. So right in the middle is where we're going to focus today: animal origin, composted materials. We can look at this in treatment as well. We'll get into that more in today's presentation about how we can treat products or either view them as untreated, and maybe some considerations there. Application, when we apply them prior to harvest, and the application method, if it's no contact with the harvestable portion, or minimizing contact with harvestable portion, or if it's contacting the harvestable portion. So, and I'm seeing here, Christy, in the footnote, the credit here is to Dr. David Ingram. So, but you also got credit, so thank you for doing that. Compost is a biological soil amendment from decayed materials. It's a controlled process, organic matter, reducing pathogens, based on time, temperature, and turnings, monitored and recorded. Compost is not, and some of you asked us in registration to differentiate this, it's not someone who stacked up manure that's never been managed. It's just, you know, a pile of something doesn't just miraculously become compost. Certain criteria for that, and it's not food scraps, coal piles, it's not unmanaged. Additional considerations here: compost contains if it contains animal materials, it poses, and this is intuitive probably for you guys, this larger risk because animals can carry and shed pathogens. Only compost materials of animal origin are covered under the produce safety rule. So as we talk about pathogens today, to be clear, it's bacteria, viruses, and parasites that cause disease in humans. And with that, we'll pass over.
So I'll be talking to you about what it means to have treated and untreated compost. So untreated compost has not gone through a documented controlled process to reduce microorganisms, and it also could mean that it has been mixed, recombined, or recontaminated, or contaminated after treatment by water, rain, untreated waste, or an untreated amendment. Next slide. So if an untreated compost is used, the produce safety rule states that it should not contact the edible portion of the crop or minimize the potential for contact with the crop after application. And so this could be seen as a either in a tree fruit situation, trellis tomatoes, or a plasticulture situation. Next slide. So the FDA is reevaluating the application intervals for all untreated biological soil amendments of animal origin. This includes compost. So until that rule is finalized, or that part of the rule is finalized, following the National Organic Program recommendations are advised. So they state that 90 days before harvesting, if the edible portion of the crop does not contact the soil, and 120 days before harvesting if the edible portion of the crops does not contact soil. And so the edible portion is from bloom until harvest. Next slide. So some tips for reducing the potential for cross-contamination of untreated compost. And this could be the recontamination of treated compost piles, tractors, people, etc., that then bring that into the production area. So untreated compost should be stored away from treated compost piles, downslope away from production fields or behind a berm to prevent runoff, under a covered shelter or tarp to avoid dispersion from wind and rain, and possible intrusion from wildlife or domestic animals. And then away from foot and vehicle traffic. Also on a cement or impermeable foundation, such as like packed clay, bentonite clay, when possible, to avoid excess leachate into the ground. Next slide. So there are 3 validated processes under the produce safety rule. Those include physical, so heat treated, chemical, high alkaline pH, and then biological, so composting. Next slide. So for compost to be considered treated, a scientifically valid method needs to be implemented that's proven to reduce pathogens. And the parameters are time, temperature, and turning, and those parameters should be monitored and documented. So the 2 scientifically valid biological methods identified under the produce safety rule are static composting, we're maintaining aerobic conditions by pumping atmosphere into the compost pile. And you're maintaining those aerobic conditions at a minimum of 131 degrees Fahrenheit for 3 consecutive days, followed by adequate curing. And then the other process that most people are probably familiar with is turn composting. We're maintaining that aerobic environment to allow those microorganisms to do work and create heat. And you're maintaining those aerobic conditions at a minimum of 131 degrees Fahrenheit for 15 days, and it doesn't have to be consecutive. There needs to be a minimum of 5 turnings followed by adequate curing. Next slide. So monitor your compost pile and either those parameters of temperature, turnings, and time will ensure that you're reducing the possibility of human pathogens, but also creating an environment that's reducing the likelihood of plant pathogens and weed seed viability. So temperature is going to be the most important aspect of those parameters, and then timings and turning are those parameters that help temperature do the work of reducing the pathogens. So you're going to measure the temperature of compost piles to assure that those correct temperatures are maintained throughout the active process. You can use a long stem thermometer as indicated in the slide here to measure that internal temperature. And you'll want to take at least 4 temperature readings at different locations along the pile and record those readings. Next slide. Time is the other parameter, and that's going to be dependent on the management practices employed, the environmental conditions, and in Colorado that could be very dependent on elevation, the aeration method, the ingredients used, and inherent carbon to nitrogen ratio of the pile, and the moisture content of the pile. It's just a reminder that's important to observe and document the number of days above 130 degrees Fahrenheit. Next slide. So the following 2 processes are turning and adequate curing. So turning is going to help distribute the moisture throughout the pile. It's going to aerate the pile to allow those bacteria to survive and create heat through work, and allow all particles in the compost to have exposure to those thermophilic temperatures. Next slide. So the final stage is curing. That occurs after that heat-loving phase of compost. Materials, fatty acids, etc., are going to continue to decompose and break down until the compost is stabilized. If proper curing does not occur, that compost can damage plants due to high levels of ammonia, organic acids, etc. And this typically lasts 1 to 4 months, but can be longer. Next slide. And I'll turn it over to Christy now.
Thanks, Beth. So now we're going to switch gears from talking about managing our compost, where you're creating that treated product, to actually using the treated product. So compost that has been treated is one of the safest soil amendment types that you can use, because it has gone through that controlled process that's eliminated those potential pathogens. So whenever possible, you want to use that treated product in place of an untreated product. And always, if you're going to be side dressing your crop, you want to make sure that you're using a treated product. There's too much risk from putting an untreated product next to your produce and potentially contaminating your produce. So that's just a practice we really recommend you do not do. And so under the produce safety rule, treated compost can be applied directly to the crop without any restrictions. with the caveat that as long as that compost after it was produced didn't become contaminated before you applied it. And so now I'm going to talk a little bit about storing compost. Next slide, please. So your treated compost, you want to make sure that you are preventing it from becoming contaminated, because if your treated compost becomes contaminated in some way, you have to use it as an untreated product. You can still use it, but you have to use it in thinking about the guidelines around using that untreated product. So for right now, that's using those NLP guidelines. So in order to keep your compost pile secure and uncontaminated, you're going to want to keep it away from your untreated compost. And along with that, thinking about the tools that you're using for your treated compost piles, you want to make sure that you're not using those tools for untreated compost that you're using for your treated piles. So when you're going out to work your piles, you always want to start with your pile that's treated and then move down to your untreated pile. Again, just making sure that you're not introducing any untreated compost into that treated pile. We always recommend that you keep your compost stored on the downslope away from your production fields. Again, that's just a good practice to prevent your produce from becoming contaminated if there's any potential contaminants up at your composting area. We always want to make sure that we do not have any vehicles or people moving through our composting area and then going out to our fields. Again, that's twofold. We want to make sure that we're not contaminating our produce fields, but then we're also not contaminating our treated compost piles as well. And some good ways to keep your produce or your compost from becoming contaminated is to either put it under some kind of cover like a tarp, or some kind of plastic sheeting, or if you have the ability to have a covered shelter where you can store your compost, that's a really good practice as well. And the reason for that is you want to, again, you're trying to prevent those treated piles from becoming contaminated from either wind, or if you have a rain event, you know, if there's water that is being washed down into your treated compost, you want to prevent that as much as possible. And then also securing it from intrusion from wildlife or domestic animals, because if you have animals contacting your compost piles, it can become contaminated from their urine or from their feces. And so, if we see birds roosting on a treated compost pile, we're going to have to assume that that pile has now become untreated, because we know that when birds roost, they poop. And so they're contaminating your treated pile. So just some things to consider as you're building your piles and locating your piles around your farm. Next slide, please. So we wanted to talk a little bit about agricultural teas. We do see them used pretty frequently on farms here in Colorado. And so these ag teas are made by combining biological materials together and then steeping them or mixing them with water in some way. And so I thought it'd be important to cover the way that, the produce safety rule identifies ag teas. So only those ag teas that contain biological soil amendments of animal origin, so those products that Adrian talked about, those are the only ones we think about under the produce safety rule. They are held longer than 1 hour. That's another caveat under the rule. And I'll talk more about that in a couple of minutes. But the produce safety rule specifically says that if you make an agricultural tea and it sits longer than 1 hour, then it's considered an ag tea under the produce safety rule. So to be considered a treated product, a controlled brewing process must be followed, similarly to making compost. We don't just have a pile of uncontrolled process or no processes at all in place for our compost. We also don't have that for our ag tea. We want to make sure that it's some kind of process is being followed and that you're protecting that process from becoming contaminated. It's important that you only use ingredients that have been treated through a scientifically valid process. So again, we talked a little bit about what that means, but if you're using compost to make your ag tea, you want to make sure that you're using a treated compost product to make your ag tea. And then the other products that go into your ag tea, you want to have some information from the supplier of those products that they have been treated in a way where there aren't any pathogens in them. Another thing that the produce safety rule identifies is that all water that you use for brewing or applying your ag teas cannot contain any generic E. coli. And so that's a really big important thing to keep in mind. You don't want to take your ag tea and mix it with untreated surface water as an application method, because that's a really risky practice, because we don't know what's in that water. And so we take this product that's got a lot of microorganisms in it, and we're going to put it, you know, into some water that maybe has other microorganisms in it, and that nutrient source can maybe feed those organisms that are in your water. So it's just a really good practice. And again, like I said, it's identified in the rule, but you don't want to have any generic E. coli in that water source that you're using. And then the final thing, the way the produce safety rule identifies agricultural teas is that if you add some kind of additive to your agricultural tea, like molasses or yeast extract or algal powder, to increase the biomass of your ag tea, the way that the FDA has looked at that is they've said that when you do that, that automatically makes it an untreated product. And the reason for that is a couple reasons. So they've, you know, when you're adding those products to your ag tea, you want to increase the biomass of your ag tea, and you want to increase those microorganisms. The problem is that you can't differentiate between the bad microorganisms, or those pathogens that we talk about, versus good microorganisms. And so it's really, when you're putting those additives in there, you're boosting all of that. And so FDA, that mentioned earlier, that ag teas are only identified as ag teas under the rule if they sit for an hour or longer, and that's because the FDA has identified that if it sits an hour or longer, then that's when the potential for those bad microorganisms or those pathogens can outgrow your good microorganisms. The research that they've done, this is what the information that they've come out with, and that's the way they're evaluating it now. Who knows, it could change in the future, but that is the way they look at it. So if you add those additives to your ag tea, it's considered untreated, and you should follow those NOP guidelines for applying those products. So again, just to reiterate, if your ag tea does not meet the requirements that I identified, then your product has to be used as an untreated product. Next slide, please. So to reduce pathogen contamination around managing your teas, you want to be sure that that water source that you're using to mix your ag tea and apply your ag tea does not contain any generic E. coli. When you're brewing your tea, you want to make sure that you have it in a covered location, or in some kind of container that's covered. And again, that's to prevent any contaminants from getting into your tea. You would never want to go out there and find a dead rat like floating in your tea. That would be really bad. So keeping a cover on it will help prevent any contaminants from getting in there. You want to make sure that if you all the ingredients that you use to make that ag tea, that you store them in a manner where they're not becoming contaminated. So I mentioned earlier, you want your product to be treated going into your compost tea, but then you also want to make sure that you're storing your ingredients in a way that they're not going to become contaminated from something. And then again, if you're using an untreated ag tea, so if they don't meet those requirements that I identified, you want to make sure that you're only applying those to the soil and never to the edible portion of the crop. All right, next slide, please. So now we're going to switch gears a little bit, and we're going to talk about those health and hygiene practices that you want to make sure that you're using and that your employees are using when you're working with compost. Next slide. So we've talked a lot about, the different ways that animal materials are a risk in your compost, and so they can be a food safety risk for your produce. And Adrian did a good job about talking about those earlier. And so you always want to handle your compost with caution, because they are, there is some risk identified with those materials. And the main thing that we're worried about is cross-contamination. And so that's when bacteria or germs are carried from one surface that's contaminated to another surface that's not contaminated. And so that's really important when we think about our clothing and our shoes that we're wearing and using for our compost production, and then wearing those same clothing and shoes out into our fields, because now whatever's on your clothing is potentially going to get on your produce if you're doing some produce activities. And then the other big thing we think about with cross-contamination is our hands. Our hands touch everything, so we always want to make sure that we're washing our hands after we handle those compost ingredients, whether that's an untreated product or a treated product. Again, it's just a really good practice to be in, that you're washing your hands after those activities. Next slide, please. So proper hand washing is vital. You know, you always want to make sure you're training your employees on the appropriate ways to wash their hands. We have a graphic on our website that you can download. I have part of it shown here that goes through the steps of washing your hands. And then the bottom part of the graphic also says when you should wash your hands. We have it available in Spanish as well if you need that. Proper hand washing is really going to prevent cross-contamination of objects on your farm, so maybe your food contact surfaces, and then again also from contaminating your produce. Some farms choose to wear gloves when you're handling the sows. Again, that can just be a really good practice because you want to make sure that you're not contaminating your produce. So if you wear gloves, it just gives you that extra layer of protection. Even if you're wearing gloves, you always want to make sure you're washing your hands after you take them off. And if you're using disposable gloves, you know, don't try and reuse them. Just throw them away after you're done. And then if you have those reusable gloves or those cloth gloves or neoprene gloves, make sure that you wash them before you go and use them for any fresh produce activities. Next slide, please. So then the other thing we think about with cross-contamination is our tools and equipment that we're using to handle and move our produce or our compost around our farms. Some tips for that: you can color code your tools. That's a good visual indicator for employees that they know that the red tools don't get used for anything other than compost. But sometimes, you know, we don't always have that luxury to have different sets of tools for different activities. So if you are going to use the same tools, make sure that you clean and sanitize your tools that you use for compost before you go and use them for your fresh produce. It's a really good idea to store your tools that you're using for your compost. If you do have those separate tools, if you can store those away from your other tools, is another good practice to prevent that cross-contamination. So you don't want your poop shovel next to your harvesting shovel. You always want to make sure that you are again, cleaning and sanitizing those tools before they're used for fresh produce. But even if you do have tools that are separate, just have them on some kind of cleaning schedule, because you are contacting, through making your compost, you are contacting some materials that may have some pathogens in them. So it's just a good practice to put those on some kind of cleaning and sanitizing schedule, you know, whatever works best for your farm. And so when we think about the tools that we're talking, that, you know, we would want to focus on are those compost probes that we mentioned earlier. You know, any skid loaders or tractors that you're using, shovels, pitchforks, wheelbarrows. So all of those things that we're using to move our compost around are what we'd want to have on some kind of cleaning schedule. Next slide, please. And so when we think about setting up a cleaning schedule, it's always a really good practice to set up a standard operating procedure, which identifies how you want to the process to be done on your farm. So you need to have that in place, and that way you can train your employees. It can really help you let people know exactly what it is and how you want them to do it. And so when you clean and sanitize these tools, you know, you're ensuring that they're free of contaminants, so they're not going to cross-contaminate to your other produce. And then if you're cleaning and sanitizing these things frequently, they're ready for you to use next time. So after you're done with your compost production for the day, if you clean and sanitize those tools at the end of the day, then you know that they're ready for you to use on another part of your farm. So that's all I have. I'm going to flip it back over to Adrienne now to wrap up.
Well, thanks everybody. We all agreed as presenters, we wanted to drive through the content and not pause too much. We know everyone is perhaps a bit saturated from online experiences. So we hope that this has been useful for you. Here's our contact information on screen. And want to mention too that this is also part of a grant from the National Institute of Food and Agriculture's Food Safety Outreach Project. You see our award number. We're pleased to begin to drive more of this program into Colorado. We've been, like many, forced to do it through virtual means. So look for more of this output from the Colorado Produce Safety Collaborative. And here is the crew, folks from CFPGA, obviously CSU Extension, the Fort Lewis College Old Fort Market Gardens, Rocky Mountain Farmers Union, and Colorado Department of Agriculture, all contributing. So really appreciate all your comments thus far and questions. And I want to circle back to one and just see, Michael Moss had asked, in categorizing a bioreactor process, a Johnson-Su bioreactor compost production method. I think the question we would try to get to, and if any of my colleagues are familiar with it, is does it result in a treated product? Are you guys familiar?
From what I know, it's a high fungal static compost, and I do not think that it's a valid process, but I will defer. Maybe Christy knows more.
Well, I would just say, in general, when we're thinking about composting processes, you can use things that are outside of those two that are identified in the produce safety rule. But as my colleagues have indicated, you have to have information that backs up that whatever process you're using is reducing those pathogens to those levels that are identified in the rule. So there are a couple places in the rule where it says that, you know, the pathogen levels have to be below a certain point. And so I'm just going to get out my rule book here really quick and tell you guys exactly what that is. I apologize. I should have had that ready. So if you look, for those of you that have taken our training, you have your handy little rule book that we like to look at when we're there. And so if you look at the produce safety rule, it's under 112.55, and it gives you the microbial standards that you would need to make sure that the process that you're using fits into. And so it'll indicate whether you have a treated product or an untreated product. And so if you have specific questions on that, just reach out to me. Excuse me, and I can help you figure that out as well if it meets those requirements.
Great, Christy, thank you. And I want to thank Seth for going back and answering some questions. You guys can monitor. We've in the Q&A, there's a tab in there for questions we've already answered. And Seth addressed Mark's question on best and affordable practices monitoring moisture levels in compost piles. So some information there Seth provided. Thank you. And I was always, and definitely imprecise, but you know, the idea that compost at that right moisture level, that it's not driven into an anaerobic state, but it's sufficient moisture for those aerobic organisms, should feel like a wrung out sponge. And clearly Seth is remarking that's not super accurate, but what he's offering there is a lot more precise. Seth also remarked on Sheila Payne's question about compost thermometer stem length, and that should be determined by the depth of the pile, reach the middle of the pile. So let's get back into the active open questions. Marty Poole asked, can you clarify if compost can be considered treated but not yet cured? Meaning, can you have various piles of compost that have gone through an approved treatment process, but the pile is at various stages of curing? Can we consider those not yet cured treated under the produce safety rule? Christy's saying no. Go ahead, Christy.
No, so the produce safety rule does specifically say that it has to go through adequate curing. The problem is that it doesn't identify what adequate is. But we do know that, you know, if you use compost that we consider to be hot, or it hasn't gone through that full curing process, that then it can actually damage your produce or your seedlings or anything that you put in there. And so we generally don't want to use that type of a product in our operations anyway from that perspective. But the rule does say that it has to go through some kind of curing time in order to stabilize it and bring that temperature down and further reduce pathogens. I just don't have a good answer for what exactly that means under the rule, unfortunately.
Cured, yep. When I was making on-farm compost way back when in the 90s, you know, the very, this is probably not even worth sharing, but from my own perspective, it was, you know, sort of the smell was one indicator, you know, if they're no longer had sort of that ammonia-like smell. So we're trying to drive towards more scientific conclusions here in processes and validation. So several of you remarked on Johnson Su. John reminding us that it is static process, as did Rich Andrews, and John is also saying monitoring temperature of the Johnson Su, temperature records. Valerie states that wouldn't that be part of the verification process? So is there any follow-up, crew, that we can do to provide thoughts back to these guys on the Johnson Su, and how to know if it meets produce safety rule standard?
Sure, we can do some research into that and follow up with Michael about that, and we can email the group as well. We have everybody's email addresses from the webinar, so we can certainly follow up. But again, I just like to reiterate that any method you're using, you just need to make sure that there's some scientific data that backs up that it is having that pathogen reduction that we need to see for it to be considered a treated product.
Great. Daniel asked, will increased aeration time help shift good or bad microbe levels when additives are used in a compost tea? So if I'm aerating it more, do I get, does it sway the outcome? Or does the produce safety rule differentiate?
So this is a big bone of contention with our ag tea users and producers, and FDA is looking at this. I can just tell you, we're just telling you how the rule is being interpreted right now, but there has been a lot of conversations around aeration and how that impacts those pathogens that we're worried about versus those good bacteria that we want. But they are standing firm on this right now, that if you are putting that additive into your product, then it has to be considered untreated. I'm sorry to be the bearer of bad news.
And it's a risk reduction stance, perhaps, on the part of the FDA. In a realm of unknowns, how do we reduce the risk of human-borne pathogens in produce?
And again, those products can be used. It's just you can't apply them directly to you can't foliarly apply them. So you can inject them into the ground as long as you're not growing a root crop. So as long as they're not coming into contact with the edible portion of the crop, you can still use them. You just have to use them in a different way. And I know that foliarly applying them is sometimes the best way and gets the most nutrients in, and you do it for a reason, but that's just the way that it's being viewed under the rule right now.
And it seems many of them, many producers could also consider injecting in a drip irrigation system. So that could be a real viable solution here if we're not dealing with edible portion as a root crop in the scenario, right? Great. Chris asked us, is sunlight considered a sanitizer? And I think to build on Chris's question, according to the produce safety rule, certainly it can kill organisms, right? The ultraviolet radiation. But what does the FDA say, guys?
So there's a lot of research being done right now around this particular topic. How much does UV and how much does sunlight impact pathogens and how they die? And so right now it's not considered a sanitizer. It's not considered a treatment, unfortunately. But there is a lot of research that's being done exploring that. So hopefully we'll get some more definitive information about that. If you're using an actual UV light as a treatment process, like a UV light system, then that's different than just using sunlight. You can't just say that the sun, since something's sitting out in the sun, has now been sanitized.
Great.
So not an approved sanitizer by the FDA.
Correct.
Laurel asked, is there testing required that supplies the CDN ratio and salinity levels in compost? So is it required?
Not under the produce, not under the produce safety rule, it's not. If you are a compost producer and you're licensed through the Colorado Department of Public Health and Environment, then they do have requirements for their different licensing. And I'm not an expert on those, I just have some basic knowledge of those. But under the produce safety rule, we're only focused on those microbiological pathogens or organisms. That's the main thing that we're focused on.
And Dixie's driving at a very important question here is, we don't keep piles moist enough, or, very infrequently will we have the issue of them being too wet, but also could be an issue on the other extreme. But how do we get better practices, Seth, maybe to you, how keeping compost piles moist enough in a dry climate? What have you seen? Different strategies people might use for getting moisture into a compost pile.
Commercially, water trucks, but.
And would that be sprinkled on, injected, drip tape, all the above?
Sprinkled is what I've seen, but.
Okay. Okay. Great, thank you. Laurel asks again, must compost be produced aerobically or is anaerobic production allowed? According to the produce safety rule. Christy, do you know?
Seth, do you want to
knows?
take that when you talked about it earlier?
Yeah, so it has to be an aerobic process to be considered a valid process that reduces human pathogens.
But we'll reiterate one more time that if you have research that backs up that your process does reduce those pathogens, you can use any process that's not identified in the produce safety rule. So I just like to keep reiterating that because I think we get stuck in this rut of we can only use these two methods under the rule, and there are other methods out there for sure. And so if as long as you have research that backs up that those pathogens are being reduced to the levels that the produce safety rule indicates, then you can use them.
Really important distinction. You know, you're not bound by there's wiggle room. They just say bring evidence and show us that it's scientifically validated.
Exactly.
Rich is asking, I'll unpack his question a bit here about vermicomposting. So what is the produce safety rule stance on this, knowing that vermicomposting is not it's a cool process. We can't heat it up, we'll kill the worms. So is that end up being an untreated product according to the produce safety rule? It's a gray area, Christy. We're still, FDA still trying to answer that.
Kind of. I mean, it's, I mean, the way the FDA looks at it right now, they're considering worms to be animals. And so I know that we all don't agree with that and we don't believe that, but that is the way that they're looking at it. And so, again, there's a lot of research being done around vermicomposting to show if the process of the worms breaking down the compost is reducing pathogens. But unfortunately, because, you know, we've never really looked at compost from a food safety perspective before. We're always thinking about it from a soil health perspective. So there just hasn't been a lot of research done that shows if pathogen level has been reduced by using worms to break down your products. And so from their perspective, it's considered an untreated product. And unfortunately as well, because they're being considered animals, that even if you aren't putting any animal origin products into your compost that the worms are breaking down, because the worms are an animal, they are being considered, it does put it into that BSAW category. So the workaround for that is to make your compost from your use vermicomposting, but then go through that secondary composting process, a scientifically validated process under the rules. So that's the way you can get around it, is to do basically like a double compost. And so at least there is some wiggle room there if you want to use it as a treated product. You can always use it as an untreated product. You know, we're just talking about from a treatment perspective, that's the way the FDA is looking at the vermicomposting.
Great perspective. And Seth, anything to add to that?
Sorry, I was looking at questions.
Okay, yeah. I'm going to drop something in the chat here. Hopefully you're hearing through this that to the extent possible, or I should say, gosh, I think it is the framework, and hopefully all of us would be pleased with this, is that FDA is looking for scientific evidence to drive policymaking within this. So they will often turn to research that's generated through the Center for Produce Safety. So I'm unaware at this point, maybe some of our colleagues know, are there any projects active examining vermicompost and its human pathogen potential?
I don't know of any through the Center for Produce Safety, but I know that there's a lot of companies who are, that are vermicomposting companies that are doing the research, and FDA is working with them, those particular companies. I don't know all of them. I only know of one of them, but I know that FDA is working with them to try and figure out if it is a scientifically valid process. So, we mentioned that the FDA is looking at the requirements for applying untreated products. And so that's under review. That part of the rules under review right now. And so that's part of a whole 5-year study that FDA is doing, 5 to 10 years, I guess we probably should say at this point. And so they're doing a lot of research, and vermicompost is one of those things that they're looking at. And they're also looking at some alternative methods for composting as well. So there's a lot of research that's being done. We'll get more information from FDA out. But we're only in probably I think we're about year 4 right now in their project. And so it'll be a little while until we get more information from them. But they are evaluating a lot of these questions that you guys are bringing up, which are really great questions. They are evaluating a lot of this information right now.
Fantastic. I want to note Eduardo Gutierrez Rodriguez, a new researcher in the Department of Horticulture and Landscape Architecture at CSU. Eduardo mentions that CPS is not doing vermiculture research at this point. You guys want to come to the CFEGA annual conference, a virtual conference. I'll put this in the chat for you and give you a shameless plug, but Eduardo is going to present there on 2 topics, one on compost tea and one on ag water treatment. So he is a great resource that's been added to our ecosystem within CSU on produce safety. So look for and introduce yourself to Eduardo. And Atlas asks the 6-week composting process Midwest Biosystems. Atlas, I think, again, this is if their process is scientifically validated or mirrors in some way what we see already written in the produce safety rule, that it would qualify. So hopefully you're hearing that it doesn't, any process that can come forward that is scientifically validated to reduce pathogens to the level required by the produce safety rule. And we didn't fully get into that, but there's some granularity to read in there of actually what those quantified levels should be. Any of that would be valid. So Daniel's given us a pat on the back. Thank you, Daniel. We appreciate that. Rich is suggesting anaerobic is not a good idea for greenhouse gas production, such as methane, which is an extremely potent greenhouse gas and is very odorous. So thanks for that perspective, Rich. And John, worm castings in compost tea, suggesting that is better to consider as untreated. So Christy, thoughts on that? Addressed to you.
Yeah, so again, that's because we don't know that vermicomposting is a validated process. It would be considered an untreated product going into your ag tea. So then it would have to be applied in a way that it's considered untreated under the rule.
Gotcha. And John is also suggesting, hey, maybe some of what we're discussing could be a SARE project. Could be, yeah, it's a great idea. Great idea. I'm going to drop the CFVGA conference website link in here. Invite you guys to come and see more of this produce safety content. Christy's also presenting there with some of our colleagues from Colorado Department of Ag, Hollis Glenn and Dwayne Sinning on FSMA and other produce safety considerations. Christy, is that, I forget our title structure in that, but.
Yeah, so we're hoping we have some updates for everybody. We're anticipating that we're going to get some information from FDA about the ag water standards here soon. We actually thought we'd have it by the end of the year, and so I'm hoping to give an update about that, and then just provide some really basic information about the traceability rule, and then cover some new resources that we're putting out through our organization.
Fantastic. Another shameless plug for the CFEGA conference. If you never participated in a virtual event, we've mapped this one out really well. We feel confident we can get you onboarded into it and have success with it. There's going to be great networking opportunity potential within the platform for video meetings native in the platform. We're going to have our same grower buyer networking session for those of you interested in visiting with buyers, be they institutional buyers, broadline distributors, etc. Dixie's asking for the address again. Dixie, look in the chat, if you will. If you can open that in your toolbar in Zoom, and you'll see a couple of different links in there that'll jump you out to it. So, so I hope you guys can attend. We've done a lot of heavy lifting trying to figure out how to conduct a virtual conference, and we think we got a really good one queued up for you. And with that, colleagues, any other closing remarks? I don't see any other questions in the chat.
I don't think so. Just thanks to everybody for joining us. I know this is a frustrating topic for us to cover, but hopefully we gave you some information. Again, if you have any questions about your specific practices or something you're doing or would like to do on your farm, please reach out to us so we can help you, you know, figure out how it fits into the rule.
Great. Seth?
Yeah, thank you.
Fantastic. And one more before we go. Thank you, Rich. You always have wonderful questions here. Additives to compost to capture additional nutrients, such as ammonium, which are otherwise lost to soil nutrients, biochar, zeolites. You guys have any perspective on that? Another great potential SARE project. I bet Rich has some knowledge of this already. So, but appreciate you bringing this to our attention and other thoughts of how we can think about in the compost process reduction of greenhouse gases. It's super important. So appreciate you guys. We'll conclude there. Our contact information is on screen and hope to see you all at CFVGA. Thank you, Christy. Thank you, Seth.
Thanks,
Appreciate
everybody.
y'all.